Here is problem number 85 on 6.3. So we have a tetherball weighing 1 pound and it's pulled outward from the pole by a horizontal force U until the rope makes a 45-degree angle with the pole here. Determine the resulting tension in pounds in the rope and the magnitude of U. So we're trying to find the magnitude of U. And so we can call this here 1 pound. Let's call that W because that is our weight. And so really the magnitude of W equals 1. So let's label things that we know. So we don't know the magnitude of U. We're trying to solve for that. So we can say that U, we can write that as 1, 0, or really it's supposed to be the magnitude of U, and then times, so it's going this way, is 1, 0, right? The y is 0 in this case. And so if we write that, that is going to be the magnitude of U times cosine of 1 I plus the magnitude of U sine of 1j. And then if you simplify that, cosine of 1 is 1. So let's just say this is the magnitude of U, and then there is an invisible 1 there, ui, plus sine of 1 is 0, so that's really 0j. Okay, so that is U. Let's talk about the weight. So the weight is the magnitude of W, and so at that point it's going down. And so we know that X is 0 and Y is -1. So we're just saying that our origin is right here at that tetherball to kind of help you out. So 0, -1. So we write this. It is going to be the magnitude of W times cosine of 0. Actually, that's cosine 0, and then plus the magnitude of W times sine of -1. So I'm sorry, this should be cosine of -1, sine of -1, and then this is I and this is J. So cosine of -1, that is going to be 0I, and then sine of -1 is -j. Okay, so that is our W. And remember that our magnitude of W, we know what the magnitude of W is. The magnitude of W is just 1, and so we don't really need to write it right. The magnitude of W, we know that magnitude of W is 1, so 1 times -1 is just going to be 1. Okay, so I didn't write that there. So this is this information, and this is the other information that we have. And then we have the rope. That's the last thing we need to talk about. So rope, we know that equals, let's say that's T for tension. So this is T. So T equals the tension, the magnitude of the tension times cosine. Now what is the angle here? This is the angle we're looking at. So if this is the origin, this angle, so if this is 45 degrees, well, it makes a 90-degree right here. So therefore, this is 45. So then this is going to be 180 minus 45 is 135 degrees. So this is cosine of 135 degrees, and that's I, plus the tension of sine of 135 degrees here. And so that is our rope. So what we know is that everything is standing still, right? So there is tension on the rope. It's pulling on the tetherball. It's weighted down. Nothing is moving. So what we can say is that U plus W plus T, that equals 0 because nothing is moving. Okay, so you said equal to 0 because it's just sitting still. So we're going to write our horizontals together. So horizontal, that all has to do with our X's or our I's, however you want to look at it. And so the horizontals are going to be referring to here, here, and here. So let's write that all together. So the horizontal is going to be the magnitude of U plus 0 plus the magnitude of t cosine of 135 degrees, and that all equals 0. So that's the horizontal. Now let's take a look at the vertical and put that all together. So our vertical is going to be these values here, 1, 2, and oh, I lost it on the side. Here it is, here. And so let's write that all in one line. And so what we're going to have is the magnitude of u times 0, or really that was just 0. We know that was 0, plus the j here, so it's just -1, plus the magnitude of t sine of 135 degrees, and that equals 0. So let's simplify this a little bit. So for our vertical, we can simplify it right away. This is 0, so that goes away. And then what we can do is let's add 1 to both sides. So let's add 1. Now we have the magnitude of t sine of 135 degrees equals 1. Sine of 135 degrees, so that's really 45 degrees. It's in the positive. So therefore, this is going to be, I'm going to rewrite it like this, 1 over root 2. And it equals 1. So we can actually solve for the tension of the rope. We're going to multiply by root 2 to both sides. So therefore, the magnitude of t is square root of 2. So this is going to be square root of 2. Now we can take this square root of 2 and let's plug it back into our horizontal here and solve for it. So we know there's no 0. So now we're going to find the magnitude of u here, which is what we're trying to find here, right? The magnitude of u. So this is going to be the magnitude of u plus the t, which is root 2, times cosine of 135 degrees. Cosine of 135 degrees is going to be negative root 2 over 2, and that equals 0. So the magnitude of u plus I could have written this a different way. So this is going to be, well, root 2 over 2. That's going to be -1 equals 0. Or the magnitude of u is 1. So we solved for it. So we found the resulting tension in the rope is root 2, and the magnitude of u is 1.